Hello, guys. Welcome back to CFD College. I'm Ashkan, and we are continuing our Tecplot training course. In this tutorial, I'm going to show you how you can generate and create streamlines in 2D simulations. So, please subscribe to the channel if you like these videos, videos on CFD, ANSYS Fluent, Tecplot, post-processing, pre-processing, mesh generation, and so on. I'll be posting 1 or 2 new videos every week. At least I try to do that. And if you like these videos and find them useful, please share them with your friends. Let's jump to the tech plot. Now you know how you can load your Fluent data to Tecplot. I usually work with ANSYS Fluent data, but you can do all these stuff on any CFD results. So let me import our 2D simulation flow over a cylinder. If you have seen our previous video on 2D contour, you know how you can create velocity contour on this domain. Uh, First, I want to show you how you can, uh, you know, create a new variable using Tecplot. As I mentioned in previous video, when you import Fluent, ANSYS Fluent data to Tecplot, velocity magnitude is not available among the default variables. So you have to uh, calculate velocity magnitude based on x and y velocities. One way, you have 2 different ways. One is through specify equations, but we have a separate tutorial on this because you can do many things with equations. The second way is to use calculation variables under the Analyze tab. So if you click on this, there are many different parameters and variables available here. Let me find velocity magnitude. It's here. So click on OK. And if you click on calculate, a new variable named velocity magnitude will be created on your domain. But to do to create any variable using this method, first you need to be sure about the reference variables. If you go to Analyze tab and then Field Variables, click on this one. You should check that U and V are assigned correctly. Sometimes it may, it might be wrong. For example, instead of x velocity, you will have pressure or x vorticity. So you have to check the variables first and then do the calculation to generate new variables. Okay, now if you look at the end of the list, velocity magnitude is available. And let me change the color bar to small rainbow and change the color map to horizontal. You know how you can modify and customize your contour, your uh, legend, and uh, you know the coloring and so on. I talked about them in previous video. In this video, I'm going to show you how you can create streamlines. Uh, you have an option here, stream traces. This is Streamline in Tecplot. So if you check stream traces, this pop-up will show up, and you have to choose correct variables for u and v, x velocity and y velocity. As you know, streamlines are vector. When you connect vectors, velocity vectors, you will have streamlines. So if you want to create, for example, shear stress streamlines, you have to change U and V to X uh, wall shear stress and Y wall shear stress. But most of the time, we have to select velocities for U, V, and if it was a 3D simulation, W. So since it's a 2D simulation, X velocity and Y velocity should be assigned for U and V. Click on OK. And we have two icons here. The first one is used for adding a single or rake of streamlines, and this icon, if you click on that, uh, you will see streamline details, settings, and different settings are available here. You can modify your streamlines. So let me close it. Decrease the size of the frame. You know why, if you have seen our previous videos. Okay, let me zoom in. No, it's okay. So if you want to create a single streamline, you have to click on this icon. And then if you click on any point on the domain, you can see the streamline uh, which passes from that point. What is rake? If you hold left click and move your mouse, for example here, you will have a rake of streamlines, 10 streamlines through the line. If you open the settings and details, you can see here number of seed points is equal to 10. So if you decrease it to 2, now if you generate that rake, only 2 streamlines, one over the beginning point and one on the end point of that line will be created. Uh, by clicking on this button, delete last, you can remove the lastest streamline, and if you click on this one, all the streamlines will be removed. So the first way to create streamlines is using stream trace placement tool, which is clicking on this button and then click on every point that you want. The direction is on both by default. If you change it to forward and if you change it to backward, you have these situations. I think there is no need to explain. We usually should work with both forward and backward because, but if you want to, for example, have a streamline from this point, you can change it to forward, or if you want to see streamline up to this point, up to a certain point, you should change it to backward. But most of the time, both, I mean, forward and backward is fine for us. What else I can tell? I think it's enough for this uh, tab placement. So let me delete uh, the last streamlines and then increase it to 10 and create a rake here and here. Okay, let me delete all, increase it to 50 and create a rake of streamlines with equal distance. So now we have 50 streamlines equally placed, located in the domain. Let's go to the second tab, lines. If you select this, there will be no line, but you can change the variable, sorry, you can change the line color, you can change the thickness, or you can write down the thickness you want. The arrowhead, if you don't want them, just deselect this option. You can change the arrowhead size 1.2 and the spacing. For example, uh, if I want fewer arrowheads, I should decrease the I should increase the spacing. If what if you want to have streamlines with another color? Uh, mainly, actually, we have two options. First one is like this. I have velocity contour in the background and the streamlines with black color. The other option is to, for example, have another uh, contour in the background, for example, pressure contour, or uh, no contour, just the shade, just the domain. And then I can, for example, uh, I can change the color of the lines to a velocity magnitude. How you can do it? You should click on this black. And here, as I said, I think I've mentioned this in one of previous tutorials. You have multi here, 1, 2, 3, 4, 5, 6, and 8. If you click on contour details, you have different contours here. First one, I uh, modified it and I select velocity magnitude for this. The second one, for example, let me choose pressure, static pressure. And the third one, mm, oh, I think it's okay. So the first contour is for velocity magnitude, and the second one is static pressure. Now, if you change the coloring, the line color to multi one, let me increase it a bit, increase the thickness. These streamlines are colored by velocity magnitude, and this one is colored with static pressure. And so the second method is to uh, choose any color, a solid color for the domain, and then change the uh, line color of the streamlines to, for example, velocity magnitude. But I usually prefer the first one, where I want to have velocity magnitude in the background and black streamlines. Okay, uh, this one I don't want to talk about it now. Timing, timing. Yes, it's good, I think, to talk about it. If you check show markers, let me increase the frame size. You can see different, you can see these circles. These are markers. You can change the size, you can change the color, and you can modify the shape of them. For example, a sphere, circle in 2D, they are the same. Uh, Diamond or any other shape that you want, but usually a sphere and circle is used. So now you have these markers, and if you go to Animate tab, you can have animation of these, streamlines of the flow actually. Let me check to see if we have arrowhead. No, it's not here. Uh, you can increase the number of cycles, for example, to 30, and you can export this animation. I think it's good to use these animations in our presentations because this way you can show your you know flow field to the audience, and you can play and change with these. You can play with and change these options, steps per cycle and number of cycles, to reduce or increase the animation speed, for example 200, or for example 5. See, this way you can control the speed of the animation. So the markers are useful when you want to have or when you want to create an animation. Another uh, another option, another capability is dashes. I don't know. Uh, Maybe you like these, but I usually prefer markers. And now, if you animate, you will see the markers and these dashes together. Term line, no. Integration, yes, I think it's good. So let me deselect these and zoom in to this area. What is step size? Uh, if you pick this point uh, to to draw some streamlines, let's see what happened. See, here we have a vortex, and you can't see anything because this streamline, uh, you know, this streamline follows the vortex and turn around, around, and around, and you can't see anything. So in these situations, let me delete last. Okay, now in these situations, you have to decrease the step size or the maximum steps. For example, if I add another 0 here and now click on this, no, it's I have to increase it a bit. And for example, 0.05. Yes, and now if I click here, you can see uh, we have a nice, a better, at least a better view of the vortex. But maybe the best way is to decrease the maximum steps. For example, instead of 10,000, if I choose 1,000, uh, or and let me use the default value. See, uh, this is now the view of the vortex using some streamlines. So where you have, if you have a streamline, sorry, if you have vortex, you need to change, you need to modify these, steps, integration steps. You have to decrease the step size or the number of steps to have a good, to have a nice looking view of your vortex. But let me zoom out. If you click on the frame and press Ctrl and F, it means zoom to fit, and you will have the whole view, the view of uh, your domain. Uh, now you can see we have these streamlines, and some of them are shorter than the first version. This is because we decreased the maximum steps. So be careful. Now I increased it from 1000 to 2000, and now you can see they uh, reach the exit of the domain. So let me zoom in again. But here the vortex is not mm, hasn't good view, so you have to, for example, delete it and change the maximum steps, because in this view you don't need to uh, have all the other streamlines. You only need to, you only want to show the vortex, so it doesn't uh, matter whether the other streamlines are long enough or not. So decrease it and play with these parameters to reach, to have a good view of the cortex. So this is all I wanted to share with you. Yes, I think I mentioned everything for creating streamlines in 2D simulations. Now you can enjoy it, but as you uh, saw, we have to play with different settings and details to get a nice looking view of our results. Not only streamlines, but also contours and even our graphs, our plots, our charts. So spend enough time on your visualization with Tecplot or CFD post or ParaView. It's not something that you can do in 1 or 2 minutes. So I think it's okay for this tutorial. I hope you enjoyed it and you find it useful for you. If you like these videos, please give us a thumbs up and subscribe the channel so you don't miss our future videos, and share these tutorials with your friends. Thank you for watching the video. Until the next tutorial, take care of yourselves and bye.